Hello everyone, and we will have a would like to take the attendance before we start the lesson. All right, so the first guide, let me see. 陳許婷, are you here?陳許婷, are you here?陳許婷, are you here? 陳學家
Here.
Yeah, present, yeah. 鄧家傑 何偉立
喺度。
林俊傑
喺度嘅。
林成漢
Hello.
李佩恒
Here.
林正漢 present? Oh yeah, I can see your name. 鄧俊熙
Yes.
鄧浩俊
喺度。
黃俊熙
喺度。
黃奕朗 not here. 鄭學明
喺度。
張思維
Hello.
yeah. 馮家謙
Hello.
何厚日
喺度。
何麗妍
喺度。
羅俊熙
喺度。
羅康玲
喺度。
梁家傑
喺度。
李晴
喺度。
李澤星
Hello.
Hello 李健樂
喺度。
馬家樂
喺度。
吳漢一
喺度。
魏俊滔譚君柔
喺度。
係君柔，跟住黃成軒
Hello.
Yeah, okay, so all of you are present, and we will start the lesson now. And to start with, I would like to give you this file. Now, this is the teaching schedule. It's a tentative one because we still don't know what would happen in the coming days. So, but we still need to plan ahead to get to know the whole picture, what you have to do, what you need to plan, etc. So I just sent, was so fail, right? every time I found that 2 days ago, I used the same platform by sending the same file, and it seems that the file cannot be sent. Anyway, I will use the WhatsApp as a platform again to let you know the file about the teaching schedule. So strange. Anyone who can tell why sometimes we cannot send file directly into the Zoom platform? Oh, very strange. Now, have you got the file? It is the teaching schedule.
Yes.
Now, so you may see the file now, the teaching schedule of 2020 to 2021, the same file that you may find on the screen. Can you see that, the screen, the one which is the same as yours that you are having? Now, I would like to briefly tell you what you have to do, right? First of all, it's a first lesson on chemistry. You should have built a very good foundation in integrated science in order to to know the chemistry better. Now, so you may find those topics including planet Earth, atmosphere, oceans, rocks and minerals, atomic world, periodic table. You may find that. Indeed, they are just part of the DSE syllabus. Okay, they are just part of the DSE syllabus, which is in book 1, A and B respectively. And we will continue on book 1B until the end. So in this year, including the summer tutorial section, we would cover that 2 books, book 1 and book 2. Okay, but of course, you will argue, Mr. Chin, actually is not right. Altogether, we have got 6 books. So this, yes, that's right. We have got from 1A to 2C. So here we go. We are now at 1B. We start from 1B. Okay, 1A, all those covered in Form 3. And for those are besides using the using books as a backbone, while you may have some supplementary notes, if necessary, with some extra worksheets, and also for those people after school you may find difficulty in understanding the topic, I may start to have a learning circle with all of you, which is just another type of tutorial for a small cluster of people who would have the same similar concern, right, in terms of understanding chemistry. Well, we may try to see if that can happen. And later on, indeed, in the past we used Facebook, but then here now we will not use Facebook nowadays. We will use Google Classroom now. So we would use it to share the exercise, the past paper, and the solution to the supplementary exercise there. And together with the Google Drive, okay, together with the Google Drive. So later on, once I've set up all those things, I will give you the link and place it in the description in the WhatsApp, such that you know where you can find. And if in case somebody would have concern have the after-school supplementary lessons, because of the epidemic situation, it's quite hard to have it for the time being. But it is planned to have it in second term. Okay, in second term next year. It is 2021. Okay, you get my point. So for the timetable, second is the timetable. Chem 1 will have got 4A and 4B classes. So we will have day 1, day 3, and day 5, all in double lesson. And in which day 3, you will have a chance to go to the chemistry lab in case you have face-to-face lesson. Okay, so while for the other double lesson, that mostly they will be held at the classroom. But of course, I will try my best if we can have a face-to-face lesson, will try my best to have any very small lab section. But of course, you may find it will be in a rush because for the first tier of having face-to-face lesson is just have a half-day school, right? You may know that, right? Half-day school. So each lesson it will take you about 30 minutes. So which means 1 hour lesson for double lesson. It will be quite hard to do experiments. So anyway, before we meet, our strategy will be a little bit different. To start with, in this lesson, for the first half, I will introduce to you what is DSE, what will be the requirement, or what will be tested in the exam, and what is meant by SBA. This year, Form 6, all SBA in chemistry has been cancelled, but not for you for the time being. So while chemistry will stress very much on the practical work, which means experiments. So SBA it is related to experiments. Okay. So this is what you need to know. Yes, you should have SBA. But don't worry, you should have SBA. But we cannot control the situation and the epidemic situation. So just hope for the best, prepare for the worst. Now, so you will have the quizzes. In case we have got face-to-face lesson, we will have a quizzes or asking you to memorize all those formula. So get prepared to have such. Okay, even though we have got online a lesson, I try my best to have it. Okay, such that you could keep this in a nice manner until we meet. Okay, as you all know, in your uniform test, this will be tested as well. And later on, before the uniform test, we mainly focus on 1B, textbook 1B, which is bonding and structure. So you may see that ionic bond, metallic bond, covalent bond, and together with different structures. Simple molecular structure, macromolecules, giant ionic, giant covalent, giant metallic, and try to relate this to the properties of the substances. So somebody will make up puzzles, so what is that? You will know it soon. Now, and around the period of uniform test, you may have a start of metal. That topic, metal, is on book 1C, metal. Okay, metal. And we will skip the calculations part, and such that we'll have got exam first. And later on, we start over the calculations part, acid base, redox, until we come to final exam. And during the summer lesson, here comes redox. Okay, redox. It is a if you don't know what is redox, they try to take a look on the application, chemical cell and electrolysis. Okay, something like that. So for the assessment framework, I cannot talk too much detail about this, especially for the lab session. We still don't know whether or not we have got enough laboratory section, but just hope for the best to have it. So we have got uniform test, the chapter quizzes, homework, or notebook if we have got a face-to-face lesson, and later on we have got a lab performance will be marked. And altogether 50 marks. For the half-year exam, we will have multiple choice and structural type questions and no fill in the blanks. Okay, so this is our common practice. So for the term 2 stuff, we will introduce to you later. Now, if you want to talk about the chemistry DSE, so what is that? Chemistry DSE that comprises 3 parts. Okay, paper 1, paper 2, and SBA. So what is mean by paper 1? Paper 1 will have got a 2.5 hour exam, in which it is a total of 120 marks. You need to finish 36 MC and about 14 to 15 long questions. Altogether, equals 84 marks, and added together with MC, 120. And for the elective part, you have to choose out of 2 out of 3 the electives, and each questions they will score is not 10 marks, it's 20 marks, and altogether 40. And to be completed in an hour. So this is more challenging part in terms of knowledge. And last but not least is about SPA. For chemistry SPA, it is mainly experiments. So what is that about? So we have got the 3 different types of experiments. One is VA, one is QA, while the other we call it, they will be categorized into other experiments. What is VA? VA, we call it volumetric analysis. So it is a type of quantitative analysis. While for QA, it is qualitative analysis. So what is the difference between quantitative and qualitative analysis? Do you know what's that? Cyrus, do you know? Quantitative and qualitative. So what is that? Can you get a guess of that?
One analyzes the number and one analyzes the quality.
Yeah, what does it mean by quality? Now in chemistry, quality, it will refer to tell you something about the identity. Okay, so you have to tell me what it is. While volumetric analysis, it is used some titration. Do you know anything about titration? The setup will be this. Okay, while the people would hold a conical flask to swirl it and let the solution run down and then do the experiment. It's a type of titration. It is used to get to know the amount of certain chemicals inside the sample. So in Chinese, so what is the difference? If you want to talk about how much amount they are found here, we call it 定量. 定量分析 to tell you how much you may find here. And qualitative analysis, you need to tell me in Chinese, we call it 定性分析. So what is that? You are going to tell me what it is. Okay, you talk about how much it is, how much content about are there, and the other one, it is what it is. What is it? Can you get my point? So we have got that 2 important lab techniques that covers chemistry curriculum. For the remaining parts, they are just categorized as experiments. Altogether, in 2 years of DSE, you need to do at least the total of 4 experiments. Okay, so 1 VA, 1 QA, 2 experiments, and which will make you 20 marks. But of course, to Mr. Chin, we will plan to have it more, okay, such that you can have enough data in order to help you score better. Okay, you can get more than me, right? I cannot just get 4 samples and then you tell the others the level of achievement. In case somebody underperform, it will much affect your SPA. So I can do nothing but try to add more experiments to you, such that I can choose, okay, some results which is quite satisfactory to submit. Can you get my point? So this will spread over Form 5 and Form 6 that 2 years. So which means in Form 4, no need. Don't worry too much about SPA. Form 4, we will not have any SPA. Last but not least is we have got a syllabus. Altogether, we have got 15 topics. So for investigative study, we will not tend to do this. But later on, we have got that 15 parts. Compulsory part and elective part. Elective part, it will be taught in Form 6, while for compulsory part, it will be taught in the Form 4 to Form 5. Okay, Form 3, you have start over this topic and a little bit this part, and we will continue. Can you get my point? We will continue like this. Any questions? Any questions so far? Now, for the details, you are going to refer to the syllabus and as well as the DSE framework. So the first one, it is more important. I would like to show you what is that. Okay, so you click it, and it will bring you to another page. Oh, I would like to share you the other page. Yes, this is the one. Okay, so you will go there, and we call that a curriculum guide. Of course, it will have about 200 pages. It will be too difficult for you to read it page by page. Don't worry, we will focus on what. Well, I will try to put you several pages as example, such that you will know what's that. First of all, it's about this page. It is on page 15. It tells you the relative teaching and learning hours for each topic. So what is the hidden message? It will tell you again certain level of scope to exam in the DSE and certain level and certain proportion that you may have. Okay, some topic that will be tested more, some of the topic that will test it less, and you may I can give you a hint. Okay, take a look on the hours. Can you get my point? Take a look on the hours and you may guess. Oh, so which means Form 4 stuff, they will not be examined too much, right? Just 6 hours. Yes, that's right. So if you found Form 3 chemistry a very highly difficult one, there will be more coming. So the next page, I will give you this one as example, Planet Earth. So you may see this page. So especially students should learn and students should be able to something. So it will tell you the assessment framework inside. It will help you better understand which one is the key part, which one is will not be assessed so often, right? You use this pages and you may help. And similarly, you may find some other topic that will have similar framework, which will help you, it will guide you understand the whole topic. And indeed, I must tell you the truth, right? This one, for this part, even for the publisher, the one to make the books, they would rely much on these pages. Do you know what is the purpose? They will help them design the pages. Okay, they will help them design the pages, what should be covered and how much it should be covered and the way to put. Can you get my point? So that's why you may see the book, the textbook, very often they will give you very similar framework as a curriculum guide. Very similar framework. Any questions so far? I would like to stop for a while and let you guys ask questions about DSE. Any questions? Now, while we are waiting, I would like to ask you guys one important questions, and you may feel free to put it down into the chat box. Okay. Tell me the following. The first one. What are you looking for in chemistry lesson? What are you looking for? And second, what makes you feel very, very difficult when you study chemistry? Okay, your aim, your goal in chemistry. Second is about your what is the level of what do you think will be the difficulty in learning chemistry? Okay. You may PM me, right? You may private message me, or you feel embarrassed about the goal. Somebody will say that I must score 5 double star, right? Mm-hmm. Yes, that is a fact, right? Somebody who tell me they learn chemistry. Mm-hmm. Genuine interest. Now, somebody would think of the DSE. Somebody would think of make bomb. Somebody would think of interest, right? Especially just found the subject interesting or use the subject to help you invent some other thing else, just like bomb. How about the others? Mm-hmm. Interest, something about interest. Mm-hmm. Anybody who is much job related, right? A decision while you choose chemistry, which is some people who want to, for example, you want to be doctor, right? Medical practitioner, and you know that chemistry is a must study subject in DSE. It is just a stepping stone, right, for you to study some other subject. Anyone who have such reason? Yeah, I know. Mm-hmm. Yeah, somebody would have got, right? If you want to collect the information about step question 1, summary of question 1, I can summarize it as the following. If we talk about summary, yes, that's right, job related. Now, if you want to talk about question 1, something about the why choose chemistry or the aim at chemistry, the goal, right? It is something like related to the following. One, the interest. You show me the interest. 2, it's something about for the job, right? For the future job, I can see something like this. The future job would include something like doctor. We will include something like pharmacist, something related, pharmacy related job, etc., or medical related job. Okay, or even somebody who want to be teacher, right? I don't know. Anyone who want to be teacher in chemistry. Maybe too hard to tell for the time being, right? So in Form 5 and Form 6, try to keep yourself, remind you yourself about these questions, right? I can, you may, I've got a number of your senior brothers, your 師兄, who try to study chemistry and finally he become the chemistry teacher, right? Just like one of his 師兄 here, right? I'm also a chemistry teacher. Okay, no need to tell from him, at least you're intelligent enough not to choose to be a teacher. Okay, so if you want to talk about the goal, you may see that too, right? If you want to talk about the goal, somebody, I can see that you would have a very high achieving students, so somebody will opt for higher grade. Okay, just like 5 star, 5 double star. Do you know the relative mass that you may need to score in the DSE? Do you know? Do you know? 5, it is about 70%. 5 star, more than 80%. And this one, more than 90%. And 5 star, it will be nearly 90, 85, I must tell. A very challenging task, I must tell. So which means that we have got a paper you need to score 90, to get a 5 double star. Okay, a high accuracy should be noted. Have you ever checked the Hong Kong statistics about the people who score chemistry? So what is the level of attainment? About in Hong Kong, about more than 30% of people will have got level 4 or up. Okay, which means that if you choose 2 persons to interview randomly, one of them must score 4 or higher. Wow. So what does it mean by that? Do you mean that chemistry is an easy subject, such that many of us may have got score a level 4 or above? The answer is no. Don't know why. Don't know why chemistry would have quite a large percentage of people getting level 4 or above. Do you know? It's because of the intake, I must tell. It's because of intake. Because those candidates are mainly they are more able in Hong Kong. So they would have a high ability to score higher. Okay, most of the people with high achievers, they will choose chemistry. So that's why they will have a very high percentage of people scoring level 4 above. Number 2, difficulty in chemistry. You may feel embarrassed to tell so. For question 1, how about 2? If you talk about how difficult it is. Okay, I'm sure you can tell, right? Any difficulties in learning chemistry? So difficult is just a feeling. But what is that difficulty? Tell me. Or memorizing. Something about memorizing. Memorize a lot of information, right? What else? Or understand the chemicals and their properties. Oh, that means you want to make sense of something, right? Now, it is not just memorizing, right? You want to make sense. For Sarah's case, right? You want to make sense of what is happening. So it is another level, right? Make sense of the concepts, the linkage of the concepts. It's not just linkage. Before linkage, you need to understand. So for memorizing, It's just like I ask you, I just wrote a thick book of the real the paperback dictionary, and I ask you to memorize those words inside. You may find it difficult, right? It's impossible, to ask you guys to ask you to memorize that for 300 and 400 pages, in which those points, those words, those vocabulary, they have no linkage. Okay, so that's why you are going to know this part. Okay, make sense of the understanding the linkage and the linkage of the concept, and that is one of the way you have to do. Can you get my point? Instead of just memorizing, right? You should try to make sense of those of the concepts. Try to understand it and try to link those concepts together. And second, it's about some more point which is more difficult, is about the chemistry. As said before, chemistry, it is in which a topic which relates the three scopes. For those who are just 3B last year, you can you may have seen that triangle before. Can you see the linkage? What are the three linkage? We are going to take a look at the macroscopic world, microscopic world, and you need to take a look on the symbolic world. And they will have the concept, the knowledge of chemistry, they will interchange and differently into those across that three disciplines. So that's why you may find it difficult. I try to pick up one example and let you know what is that. Now, for example, can you describe anything about NaCl, right? NaCl, what is that? It's a type of table salt, right? So it is a white solid at room temperature and pressure. Okay, it can dissolve in water. So you may have that 2 points, right? While the most difficult part, do you know what is that? Yes, that's right. This is this part, right? The microscopic world point. Try to explain what 1 and 2. And you have to use the chemistry knowledge to help you explain 1 and 2. Wow. Do you feel that Mr. Chin would like to have a start of the topic? Are you ready? Now, do you want to have a breakfast? No need. No need. Good. So for the time being, please get please take out your textbook 1B. Textbook 1B. Just go to your work, your benches and find it. Do you find it? Textbook 1B. Do you have it? We turn to Unit 7, Ionic and Metallic Bond. I would like to show you the pages. So you may find this one. Can you see this? Now, chapter 7. Anyone who do not have the book, just double check if you have got all of you have got the book. Anyone who don't have the book, please put up your hand and let me know. Or if do I need to send you the soft copy of this? So see, all of you have got it. For those who have got the book in hand, could you please put a tick here? Let me know. You have it. You don't have it, cross. How about the foreign students? 魏俊滔、馬家樂。Yeah, you find it? Yeah, good. 馮家謙、張思維 you have it? You have got the book? Now, as said before, somebody will know, who can locate the soft copy on the Google Drive, Google Classroom, right? You may download it for easy reference. 林成漢and 林俊軒, do you have it? Yeah. Shall we start? Now, the ionic bond, and we will start over the book, the topic about ionic bond. Okay, methyl bond we will leave it later. Why do I say so? For sodium chloride, what I just mentioned, it is a very special material. Okay, it is very special chemical, sodium chloride. So we have got 2 points. One is the solid at room temperature and pressure. Do you know the melting point and boiling point? Do you know what is the melting point and boiling point for sodium chloride? Try to search in the web and tell me. What is the melting point and boiling point? Search it now. Second, it dissolves in water, right? And 3, sodium chloride, and it would conduct electricity, right? Melting point 801 unit place degree Celsius, right? And a boiling point. Yes, more than 1,000, right? More than 1,000, 1,465, right? Something like this. So we would describe it as a high melting point and boiling point solid. Okay, and dissolves in water, and finally, is it conduct electricity for sodium chloride? Very strange, right? That point is
aqueous solution.
In aqueous solution. So which means that it is conditional, right? They can conduct electricity in certain situation. Right? In aqueous solution, yes. So how about the other state, such as solid? Because mostly NaCl will call it as solid, right? Can it be conducted in electricity? Indeed, it's no, right? So you may have some other situation which will help you understand what is meant by conduct electricity. So it is the physical state dependent. Okay, it depends on what situation they are having. So what do you tell about these special materials? Is that, well, if you want to talk about from the high melting point and boiling point in sodium chloride, which means that the particle that makes up the particles inside the sodium chloride, right? They are held by some strong attraction force. Do you understand? Do you understand why melting point, boiling point is an indication of attraction force, right? Do you understand? When you're long, do you understand what is that?
Yes.
Can you further explain, right? If in case the material has low boiling point, and low melting point, what is the hidden message?
They have the weak attractive force.
Okay, weak attraction or weak attractive force between what? Between what?
The iron.
Between the iron. Now, it depends on what materials you are talking about. So in order to generalize the whole thing, I will use the word particle, okay? Particle, because we do not know the nature of bonding. So of course, NaCl, you know, is ions inside. So the particles refer to ions, right? For example, ions. So it can be some other type of particles in the world that hold them together by different type of force. Okay, so to start with, in this chapter, we'll start with this. So if you want to talk about conductivity,導電性啊, so you may have 3 different types of materials. In Form 1 or in Form 2, you may have heard of these 2 terms only, right? Or you use the word insulator to tell the conductivity, the difference in conductivity of different materials. Okay, conductor, non-conductor. So what does it mean by that? Conductor, which means they can conduct electricity during the electrical conduction. Okay, non-conductor, which means they do not, right? But sodium chloride is a very special example, right? If you want to talk about sodium chloride solid, it does not conduct electricity. But once I dissolve it into the solution, okay, and I try to, and you may find the solution here can conduct electricity well. Now, just like what you know it in chapter 3 for oceans. Do you still remember? You are going to electrolysis of seawater, and finally they have got different products such like hydrogen, chlorine, and sodium hydroxide, right? Do you still remember? So the seawater is mainly sodium chloride solution. So you may see that first of all, it's about conductivity. They would only conduct, they will not conduct electricity in the solid state, but they can do so in aqueous solution. But also, if you can manage to increase the power and try to make it melt, molten state, which means it is liquid. Aqueous solution, which means what? Plus water. So can you find the difference between sodium chloride liquid and sodium chloride solution? For example, I use this one as an example. Can you see the difference between the two? Now, sodium chloride liquid, you may need to increase the temperature more than to more than 800 degrees Celsius. Okay, very hot, right? Try to increase more than 800 degrees. Only sodium chloride, no water. Can you get my point? How about sodium chloride solution? Okay, at any temperature, you can have sodium chloride solution, and you may find inside it is a sodium chloride plus water. Both of them, they are free moving, I must tell, but the composing particles, they are different. For sodium chloride liquid, we can only get what? Sodium chloride, but this is in liquid state. But for sodium chloride solution, it's not just sodium chloride, but also water. Do you understand? And next, what is more important is about the conduction of electricity. After the conduction of electricity, here comes the chemical decomposition, 分解, breakdown, which means breakdown. So I try to use this as example. Sodium chloride solution, they will break down into hydrogen gas, chlorine gas, and sodium hydroxide. Okay, so this is a very special point about this material. That material, first of all, it can conduct electricity only at the molten state or in aqueous solution. Second, but not in solid state. And second, during the conduction of electricity, it will decompose. It will decompose. It will decompose into simpler chemicals. So what we'll call it is not conductor. It's not conductor. We call that electrolyte. 電解質. Have you ever heard of this term? 電解質, right? Where will you heard of this term before? 冇抗力, is it? 冇抗力. What else? 冇抗力. Pocari. Pocari is a type of sports drink. If you take up the sports drinks and take a look on the food label, so why is it so called electrolyte? Can you get my point? Try to search it on web for me. Why is it? Can you search it on web now? Tell me why is it set as a Pocari? It is a type of, can you see that? Pocari sweat. And you search for the food label here. You click it. Try to see what is that inside. So you may see sodium, right? Sodium content is very high, right? Sodium. So indeed, it's not a metal. It is a type of salt. You know it. So if you drink it, you may have some taste, right? It is a little bit salty. Now, this one is better. Can you see that? You may see the food label here, right? So you may have the electrolyte concentration. You may have sodium ion, potassium ion, calcium ion, and this one magnesium ion. And in ion, we have chloride, citrate, lactate. Lactates come from lactic acid. Lactic acid, 乳酸啊. Citrate, what is that? 檸檬酸, 檸檬酸鹽. Can you get my point? So, what do you know about this? Well, indeed, it is not just water, right? Pocari soft drink, a sports drink is not just it's not just water. It would have some salt added, right? Some salt added. What else? Sugar added, right? Give me know. Sugar. We have got sugar content 6.7 gram per 100 millimole. But of course, you will not drink that less, right? You drink the whole bottle. So be aware of the sugar content. It's just 100 ml. It will cost you 6.7 gram. It will make you fat. Don't drink too much. Do you know that, especially for those sports person, who always love to play sports, who are quite sporty here. For example, Deng Junhei, right? You know it. Don't drink too much.
Okay.
So he becomes fat.
Becomes fat, right? Sugar. And also salt content. Can you see that? Indeed, sports drinks, once you drink it, so what is the use? It will help you recover very, very soon, because we have got some sugar. If you have got tired, fatigue, we call it fatigue, we will take in sugar. And the muscle will have a spam, so it is a loss of electrolyte. They maybe have a sign of electrolyte. So that's why you need to drink something a little bit salty, especially sodium ion. Do you know it? Okay. For those people who walk around the mountain, you may somebody would tend to have it as well, because you sweat too much. Your muscle may have got spam. It's not just fatigue. It's not just tiring, but also they will have spam, right? The uncontrolled contraction of the muscles. So you need to drink something salt containing. Do you know it? Okay, so this is what you know it about Pocari. It's an electrolyte. So what will happen if I put electricity to it? Okay, it can conduct electricity, but also it will decompose. Okay, you get my point? It will decompose. Decompose to what? It is another question that you will know it in electrolysis. Any questions so far? Difficult? So, if you use this electrical conductivity as a category to get to know the different substances you may have, the substance is not just purely metal and non-metal. Because metal and non-metal, it is just, we call it as element. We will consider compounds. For the compounds made up of, normally, underline this term, normally they are made up of metal and non-metal. We will call it electrolyte. Normally. And the compound, they are made up of non-metals. They are normally non-conductor. Just like what? It's not just sodium chloride, but also potassium oxide. The compound just like ethanol. Ethanol, what's that? Alcohol, right? 乙醇, candle wax, 蠟燭嗰啲蠟啊. And also they conduct electricity, so this non-conductor. So why was it like that? Because they behave very differently, because they have got different type of force. So that different type of force we call a chemical bond. Chemical bond, 化學鍵. So whenever you see the word bond, it is something like attraction, a type of attraction. Okay, a strong attraction, we will call it a bond. In particular, it is a strong attraction. Okay, can you get my point? So in short, you may have this table to summarize what we are having, right? Conductor, we've got any metal, copper, magnesium. How about mercury? Mercury, is it a conductor? Mercury.
Yes.
Yeah, mercury is also a conductor, but it's very special. It's a liquid metal, liquid conductor. Second, do you mean that non-metal, they are not they are non-conductor?
No. Carbon in graphite.
Yes, carbon in terms of graphite, right there. Graphite, it is also a conductor. Okay, so this is what you need to put, right? That too a very special case which belongs to conductor. So non-conductor, what is that? You're just made up of ethanol. Ethanol, which is CH3, CH2OH, as said before. Our candle wax, it is a CXHY type, but X and Y is a very large number, very, very large, more than 20. So large that it stays as solid. And if you want to talk about chlorine gas itself, if you talk about sulfur element, right, sulfur solid itself, it's also a non-conductor. Okay, so either compound or non-metal. And just like what is said as electrolyte, first of all, it must be a compound. Okay, but not element. No element is a electrolyte. Second, the compound, it must be ionic compound. All of you, please mark it down. It must be ionic compound. So what's special about ionic compound? Ionic compound, remember that term, you need to memorize. They can conduct electricity in molten state or aqueous solution, but not in solid state. Point 1. Point 2, it's not just that. There is a chemical, all of you please mark it down, decomposition during conduction of electricity. 當導電期間會點啊？會有化學分解。We have got that two category conditions that fulfill in order to set it as electrolyte 電解質。Okay, can you get my point? 電解質。Questions? Now let me ask you some examples in order to get to know what is meant by electrolyte. For example, how about sugar, table sugar? Is it a conductor, non-conductor, or electrolyte?
Electrolyte.
Electrolyte. Electrolyte, why? Bonilon, you just tell me as a
because it's a compound of metal and non-metal.
Sugar. Can you tell me the formula of sugar? Is it metal and non-metal? Is it made up of metal and non-metal? Sugar. Table sugar. Table sugar.
No, not made up of metal and non-metal.
Yes or no?
Not really. Not really. It is a non-conductor. Table sugar is in here, right? It's table sugar. It is C12H22O11. It is in terms of sucrose. We will call that altogether. We have got so many atoms that stick together, but it's not by ionic bond. It's by covalent bond to form a molecule. No metal. So it is non-conductor. Okay. What else? Let me think. How about lime water? Lime water. Is it a conductor, non-conductor, or electrolyte? Lime water.
Non-conductor.
Non-conductor. Why?
Because the bonding between them is not ionic bond.
The bonding between them is not ionic bond. So what is that bond?
Wait, let's see. Covalent bond what?
Covalent bond. Somebody will think it's covalent bond. Now take a look on lime water. Lime water, what is that?
Lime water係個 conductor。
Lime water, the formula is calcium.
OH2.
Yes, hydroxide bracket 2, right? So if you split that into half, you may find calcium ion and hydroxide ion. Lime water, it is indeed in water, right? So it is freely moving. The ions are freely moving. So it can conduct electricity at solution state, right? In aqueous solution. And later on, they will have a chemical decomposition after conduction of electricity. So lime water is here. Okay, lime water is here. Can you get my point? Lime water belongs to this example. Okay. How about plastic wrap, plastic food wrap? Do you know what's that? Plastic fruit wrap?
梗係 non-conductor 啦。
Non-conductor. So tell me what is the chemical that makes the food wrap? So you know that, right? The way to judge is easy, but the explanation is a little bit difficult.
Let me ask Google.
Let me just ask the god of Google. What is mean by the food wrap, plastic food wrap? 保鮮紙啊 Do you understand? 保鮮紙 Cyrus, do you know what's that? What makes the plastic food wrap?
Siri is rubbish.
What?
I cannot find it.
Plastic.
PVC.
PVC. No, it's not PVC. It's
PVDC.
PVDC.
Not PVC is a type of plastic. We call that PE. PE, polyethylene. Okay, 聚乙烯 is a type of a polymer, a solid, right? But it is a very soft solid. So PE is a type of polyethylene or polyethylene. And inside that, what's that? What is polyethylene? Polyethylene, it is made up of carbon and hydrogen connected repeatedly like this, okay? We've got so many units on the left-hand side and right-hand side connect with each other. Okay, so in this teaching is so lazy, I just want to make a middle bracket to tell, right? Indeed, what is mean by that, for the middle bracket? That unit repeats. That unit repeats. Can you get my point? A very, very long chain. So no metal containing. So you may find whenever I see the solid line is no iron, right? There's no iron here. So it's a non-conductor. Can you get my point? So can you get my point? So we start to talk about in detail what is happening. I try to take a further look inside. What I've just mentioned is just macroscopic viewpoint. Can you see that? Here, they are just macroscopic viewpoint. 睇緊宏觀嘅嘢。What does it mean by macroscopic? Something that you can see. Okay? And for some instance, in order to answer the questions, I ask you guys to think of symbolic viewpoint. Symbolic, which means I ask you guys to think of the symbols and use the symbols to help you judge whether or not it's non-conductor, electrolyte, and conductor. Can you sense it? And finally, in the final 10 minutes, here comes microscopic viewpoint. More difficult, right? Indeed, why would those electrolytes can conduct electricity in room temp at molten state or in aqueous solution? It is because of the presence of ions. While ions, they are responsible for the conducting electricity. Okay, so this is the ions. Okay, and only for those chemicals we call it ionic compound, they will have such behavior. Okay, can you get my point? So I would like you guys to have a take a look on this. You are going to electrolysis of molten, search on the web now, molten chemical, molten lactobromide, for example. So you may have got this.
This rock contains aluminium oxide. Split the aluminium from the oxygen and you have one of the world's most useful metals. You can split a compound using electricity. The idea is to pass an electric current through it, a process known as electrolysis. A circuit is set up using 2 carbon electrodes, an ammeter, and a power supply. The white powder is lead bromide.
Lead to bromide, okay?
Switch on the power supply, and nothing happens. The ammeter reads 0. Solid lead bromide doesn't conduct electricity. It needs to be molten. Lead bromide melts at 370 degrees Celsius. Switch on now, and a current flows. In this circuit, the electrode on the right is positive, the one on the left is negative. As electricity passes through the molten lead bromide, chemical reactions start. On the left, at the negative electrode, nothing appears to be happening. But at the positive, bubbles mean a gas is being produced. Placing small tubes around the electrodes traps any gas, making it easier to see their colour. What could the brown gas be? The gas is bromine. Although nothing obvious appears to be happening at the left-hand electrode, pouring the molten lead bromide away reveals a small silvery metallic bead.
Silvery liquid, can you see that?
This is pure lead. So, passing an electric current through molten lead bromide breaks it down into the elements lead and bromine. To work out why this happens, imagine you can see the charged particles, the ions, in the compound. There are positive lead ions and negative bromide ions. Once the power supply is switched on, the lead ions are attracted to the negative electrode. The bromide ions are attracted to the positive electrode. Lead ions pick up electrons. They lose their positive charge and form lead atoms. Bromide ions give up electrons. They lose their negative charge and become bromine atoms. These form a gas. Electrolysis of lead bromide only works when the compound is molten. Why doesn't it work when the compound is solid? Change the compound from lead bromide to zinc chloride and the products of electrolysis will be different. What would you expect to see happening when electricity is passed through molten zinc chloride? This time, bubbles of a very pale gas appear at the positive electrode. It turns damp blue litmus paper red and bleaches it lighter. So what gas is it likely to be? Again, nothing appears to be happening at the negative electrode on the left. But pouring off the molten zinc chloride reveals a bead of pure zinc. In industry, electrolysis is carried out on a huge scale. Massive amounts of electricity are used to extract reactive metals, like aluminium, from their ore.
All right, so I'm sure you know some of the important parts in the concepts. Now, by the end of today's lesson, we would like you guys to try by writing, by the drawing, what really happened when you are having lead-2 bromide. Using similar diagram on this page, okay? Lead-2 bromide. Can you write down on here, on the left-hand side? Left-hand side. So you may have got connection of the electricity, very similar, right? You are going to have it lead-2 bromide. Lead-2 bromide. For solid, can you write down what happens about solid state or also in molten state? Molten state. What happens to that too? Okay, so we have got that part, which is the electrode, the electrode, okay, the graphite electrode. So can you tell me the difference between the solid state and molten state, which would help you explain why one of them conduct electricity, one of them do not. And second, for those who conduct electricity, there is chemical decomposition. Only this, okay? Can you tell? I have got maybe anyone who have got a pen, okay, you may draw it on here, on the screen. Anyone who have got a pen? No? You don't have it? Or maybe you explain it orally. Anyone who can help? You may explain orally. In written, or in written is also okay. Anyone who can tell about that two scenario? No?
I try.
Yeah?
So for solid, so when lead bromide is in solid state and the particles is held in a fixed position, so they cannot move freely.
Okay, they can held in a fixed position, right? Held
Yes.
in fixed position. What particle?
Lead and bromine.
The ions, right? The ions. So we have got two ions. We've got, first of all, like two ions and bromide ions. So what would we imagine about the hacking about electrobromide here for solid? What will happen to this? We've got so many ball that will stick it like this way, okay? Just like what you imagine in Form 1. In Form 1's science, right? You write down solid, you will be asked to draw something like a regular arrangement, right? Regular arrangement. So lead 2 ion, for example, a red one is lead 2 ion. And the bromide ion, it is something like the blue one. So can you locate where is the red, where is the blue? Can you tell? How would you place in solid? Do you understand? Anyone who can try? Yes, something like this, right? Good. Something like this. They put it into alternative manner, right? So red and then green, red and then green, red and then green. Yep. Red and then green, red and then green. So if you want to make it as a higher standard, I may say it is in 1:2 ratio, right? This one is 1 portion, this is 2 portions. It will be quite difficult to draw, right? For time being, just understand. This part I would not stress too much of that, but my focus is on here, right? So you may find the red one and the blue, the red one, the green one, they are placed in an alternative manner. Can you get my point? And then what's next? What's next? What's next? Tell me. Yep, because they are held in a fixed position. So what happened? They will not move, right? They are held in fixed position, which means not moving. Not moving. So in chemistry term, we call it not mobile. Freely moving, mobile form, right? So they will not conduct electricity. Can you get my point? Do the same thing if you want to talk about molten state. So what will happen? At molten state, which means that what happened to the particle? The particle will become freely moving. Okay? First of all, write down the ions become freely moving. So we'll use the adjective. What is that? Mobile. The ions become mobile. So they will be moving in certain direction. You may see it on the zinc chloride example, right? Zinc ion and chloride ion, they will move it in their own way. Now take a look on the symbol, the battery symbol. It is plus and this is minus, okay? So something they will move towards left-hand side, some in the opposite side. Tell me which is which. Yes, the green one. The green one here, while the red one on the right-hand side. Can you get my point? Why? Because the red one is positive charge, which will be attracted towards negative electron by electrostatic attraction. Can you get my point? It is a negative ion, of course, they will be attracted to the positive electron. Opposite charge attract. Can you get the point? Opposite charge attract. 異性相吸. Okay? You can get what I mean, right? So because of this, you may, from the macroscopic point, you may see there is a directional movement of charge. Okay, so we will say that it conducts electricity. So of course, you may use ammeter in your video, but in chemistry lab it's easy. You use the light bulb, right, to tell. In case the light bulb is on, I know that one can conduct electricity. Can you get my point? So first part, it will tell you it is a conduction of electricity. Second, as said before, there are chemical decomposition. Why? We will take a closer look on the electrons, right? The electrons. Once the Lead-2 ion receive electrons, what will happen? Lead-2 ion, they will receive electrons to form
Atom.
Yes, the atom itself. Okay, so the Lead-2 ion, 2 plus electrons to form lead metal. Very similar to what you may see on zinc, right? You are going to do something similar. And similarly is on the bromide. Bromide, what will happen to the bromide? They will lose electron. Bromide ion, they will lose electrons. So electrons will be put here, right? So what will they form? They will form bromine. But wait a minute, Mr. Chin, bromine. So what is the what is it? Bromine. Bromine, it is not stable in as atom alone. It exists as molecule. So you may find it Br2 as example. Br2. So similar is chlorine. Can you see that? Chlorine, they would work together to form Cl2 as a molecule, and they will leave. So that's why you may see one electron will have got brown gas, orange gas. While leaving behind, you pour all those electrolytes and you have got silvery liquid. Silver liquid, it is on here, right? Silvery liquid. While for bromine, so what is that? It is a reddish brown gas on the other side. Do you understand? Do you understand? In order to check your understanding, please go home and finish question 25 on page 107. Page 107, question 25, okay? And you may have this. We'll like to have it next week and try to check your understanding, whether or not you understand what is that. Do you find it difficult? What do you think about this?
Okay.
Okay?
Acceptable.
Okay.
Not too difficult, right?
Acceptable.
Okay. Now, so you see, this time it is something about microscopic point, right? To explain something microscopic. Yeah. Yep. 7H. Really can manage. Oh, quite glad to see this. Okay. I'll just stop it here and you would enjoy your lunch.
Mr. Chin.
Yeah.
Yes, I want to ask in this case, is it the bromine ion will stuck to the positive electrode in two together. Is it like a pair?
Now, it depends on the element stage. It depends on the element stage they want to behave. So chlorine, bromine, they are very similar. Chlorine, bromine, iodine, fluorine, they are similar. In the element stage, they exist as diatomic molecule. So simply speaking, for the bromide ion, it is separate Br minus. So we need two bromide ion that attract to the electrode. They each of them lose one electron, and they will form three bromine atoms, and finally they will merge together to form chlorine gas and leave. Okay, similarly for bromine. So that's why in your equation, you may see the equation they write as 2Cl minus to form Cl2 plus 2 electrons. That two here will tell you how many chloride ions are needed and how many electrons are going to lose. And finally, in case we have got two ions, they will form one molecule only. One molecule only. Okay? So as shown in your diagram here. So similar case for bromine. Bromine is still the same. You understand?
Okay, thank you.
Yeah. Okay, any more questions? Any more questions? Okay, as said before, check it up on the page, page 107-25 and do it at home, and you will see you guys next week. For the memorization of the ionic formula, I try to make it in the Google form and try to see if it happened. Okay? Keep in touch in your Google Classroom as well as WhatsApp. Have a nice weekend. Bye-bye.
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 Bye.
Bye-bye.
Bye-bye.